All right, welcome to Geometry 10-3. We are studying conditional probability formulas. And conditional is almost something that we just did in the last chapter, which is basically saying a conditional probability is saying for any two events, A and B, what's the probability of B occurring given that A has occurred? And this is something unique that we haven't done so far. So once again, what is the probability of B happening given that A has occurred? And how to solve this will be the probability of A and B over the probability of A. Let's look at an example. So in problem number 1, it says a little bit of information here. There's a group of testers, and half of them, to see how well medicine works, half of the testers, or 50%, got the drug, and the other half didn't. They got a placebo. The placebo is just it's basically like a piece of candy. There's no real drug in it that will make you better. It's just a fake one. And this is saying, and then also the probability of getting a drug and getting better was 45%. So what's the probability getting that you got well given that you got the drug? Let's just zoom out here real quick and see what this is asking. The question is saying, what's the probability that you got well given that you got the drug? So you have to have gotten the drug, and if you did get it, what was then the problem that you got well, or the probability? We know that half got the drug, we know that half didn't, and we know that of getting the drug and getting better was 45%. So, but that's just part of this category. So what's the probability of getting well given that you got the drug? So here it is. What is the probability first of getting well given that you got the drug? So we got the probability of A and B. Well, the probability of A and B happening is 45%. It says there, you got the drug and you got better. And, not given, and, right? That's 45%. Divided by the probability that you got the drug is 50%. And if you divide this, 0.45 divided by 0.5, you get 90%. Meaning there's a 90% chance that out of all the people, you first fell into this category that you got the drug, and then out of those 45 of you got better, so that's a 90% chance. Let's look at a different one. So same scenario here, or same question, right? We're talking about conditional probability, but new situation. 45% of people in a population own a dog. 20% in a population own a cat. 12% own both a dog and a cat. So right now I want you to see it's more likely that that you would be a dog owner first and then be part of this category that you also own a cat. And it would be a smaller probability that you're a cat owner first, because it's just 27%, and then that you'd also be a probability of being, that you'd also own both. So let's look at each of these individually and see how this plays out. So again, the first one is, I'm going to use purple here, orange. What's the probability, what is conditional probability that a dog owner, so given that they own a dog, will also own a cat? Do you see how that works? So it's probability given that you're a dog owner, so that's this, and that you own a cat. So what's the probability you own a cat given that you're a dog owner, right? So this is the main thing, the dog owner. The cat is this extra one, right? So what's the probability that you would own both, right? Well, 12%. There's a 12% chance that you would own both. So it's 0.12 over the probability that you would first own a dog is 0.45. And that equals 0.267, or 26.7% chance that you would be a dog owner and also own a cat. Let's look at the opposite of this, or not the opposite. Let's look at what's the probability that you're a cat owner, you're given that a cat owner and you own a dog, right? So this should be smaller because it's only 27% compared to the 45. So the first is, what's the probability of both these? Well, we do have that. It's 12 again. So 0.12 over, what's the probability of owning a cat? 0.27. And this equals 0.44, which equals 44.4%. Let me just see where I made a mistake. Okay, I do see where let me just explain this one more time. Let me get a different color here. Let's think about it like this. Let me go to a new one. Actually, let me just erase some of this. I'm just wrong with my percents. I'm sorry, my math is all correct. but I want you guys to see something here. Okay, so that's our 2%. So actually, we have a smaller chance that you would be a dog owner and then own a cat than you would being a cat owner and then having a dog. And let me look at why. And here's the why. The why is because there's a smaller amount of people that start off with cats, right? So let's say this is 27%, and the rest is 73%, right? And kind of the most easy way I could say it is this. Since more people own a dog, you have a wider margin of people compared to that are entering into just owning a dog, right? And then they have to go down from this wide part to a narrow part, which is owning a cat, right? Or on this end, if you own a cat first, right, if you can get in, if you're one of these 27%, then since 40% of the people own a dog, it's actually going to be a higher probability that if you get in here, it opens up wider, right? Where here, if you get in, it actually comes down and it's more narrow. So that's why this is actually going to be a harder thing to do. 26.7% of people or less going to be dog owners and then have a cat. All right. Good luck. Talk to you later. Thanks. Bye.